Hi everyone, and welcome back to the channel. Today we are going to discuss about PC817 Optocoupler in LTSpice. This is little component allow us to electrically isolate different parts of our circuits, which is crucial for safety and preventing unwanted interaction. In this video, we will break down how the PC817 works, how to set up a stimulation in LTSpice, and analyze the result. What exactly is a PC817? It is an optocoupler, meaning it uses lights to transfer a signal between two electrically isolated circuits. Inside the package, we have a photodiode on the input side and a optotransistor on the output side. When the current flow through the input diode, it emits the light. This light then shines on the optotransistor, causing it to conduct on the output side. The key here is that there is no direct electrical connection between input and the output. The signal transmitted optically, providing that the crucial isolation. In fact, the PC817 is known for impressive 5 kilovolt isolation capabilities, as we can see in the datasheet. Now let's look at our LTSpice circuit. We can see the input side with voltage source and a resistor to limit the current through the photodiode. On the output side, we have a phototransistor connected to the another voltage source and the load resistor. Now you might notice that in our simulation here, we have a common ground for simplicity in demonstrating the bias operation. However, it's absolutely crucial to understand that in real world applications where you need the isolation in the primary and the secondary side of the circuit will be completely separated with the ground connection. This is the whole point of using the optocoupler. To get the PC817 working, we need to bias the input diode correctly. In this example, we are using 5 volt supply and the resistor set the diode current to the 5 milliamps as per the datasheet. This is the common operating point of this device. Another important part of the optocoupler is the current transfer ratio or CTR. This tells us the ratio of the output current to the input current. That means CTR is equal to IC divided by IF, the forward current of the diode and the collector current of the transistor into 100%. As per the data sheet, will be 50% at the forward current of the diode is 5 milliamps and collector to emitter voltage of the transistor is 5 volt. As per this formula, the collector current will be 50% into IC divided by 5 milliamps into 100%. So that the IC is equal to 2.5 milliamps. Meaning, if we have 5 milliamps going to the diode, we can expect up to the 2.5 milliamps out of the transistor, and it is depending upon the load. We are going to run the transistor analysis to see how the output respond to change the input, and we have set the stop time to 5 millisecond which should be enough to observe the few cycle in the inputs. For our input, we are using pulsating voltage with a frequency of 1 kilohertz. This will allow us to clearly see how the optocoupler transmit the signal. Alright, let's learn the simulation and see what we get. Here we have a input voltage waveform and our output voltage waveform at the top. Take a look at this. Notice the inverse relationship between the input and the output. When the input voltage goes high to 5 volt, the photodiode turns on, the phototransistor conducts, and output voltage drops to low level to 0 volt. In our case, it is almost near 150 millivolt. Conversely, when the input goes low, the diode turns off, the transistor stops conducting, and the output voltage goes toward the full up voltage. This demonstrates how the PC817 effectively transfer the on and off signals from input to isolated output. The PC817 is versatile component and can be used in a wide range of applications where isolation is needed. This includes driving relays, creating isolated relay circuits, controlling motors, and interfacing with various other type of loads. I hope this tutorial has given you a clear understanding of how simulate the PC817 optocoupler in LTSpice and its basic operations. If you found this video helpful, please give a thumbs up and subscribe for more LTSpice tutorial and electronic project. Let me know in the comments if you have any questions or suggestion for future videos. Thanks for the watching. I will be see you in the next one. Thank you. Thank you for the watching.